What's the first thing you need to do? We did this a bunch of times. True. What else could you find first? You could find, if you have y1, right? What's y1 going to be? 1 plus 2 minus 4 is going to be what? So the point is 1, negative 1, right? You're now trying to find the tangent line at that point, correct? Trying to find the tangent line at that point. So what do we need to find? The derivative of the left side here. Let's call this f of x. So what's f prime of x going to be, Noah? Correct. So what's f prime at 1? 3 plus 2 is what? So what's the equation of the tangent line? Y minus negative 1 equals 5 times x minus 1. Where does that correlate? The negative 1 is right there. The 1 is right there. And the 5 is right there. Are we okay with that? What form is that in? Is that in slope-intercept form? Point-slope form. Thank you. Very good. So let's isolate y. Y plus 1 is equal to 5x minus 5. So y is equal to 5x minus what? 6. Okay. So that's the tangent line. So we're interested in finding out where this what? We want the what intercept? The x-intercept. So when y is what? You're about to say it. So that's when y is 0. So you have 0 is equal to 5x minus 6. So x is equal to what? 6/5. So this is also now called x2 is equal to 6/5. We now do the exact same thing, but with 6/5. We do the exact same thing except with 6/5. So if we have 6/5, what do we now find? y2. How do you find y2? Into the original equation, right? Not to the derivative, the original equation. Is this something you might want to use your calculator for? The slope. So you have y prime evaluated at 6 over 5. What was y prime? We had it up here. 3x squared plus 5. So it's going to be 3 times 6 over 5 squared plus 2. Thank you. So it's going to be 3 times 36 over 25 plus 2. Equals over times 6/5. So we're interested in finding out what x equals when y is equal to what? So we want it when y is equal to 0. So what do we end up with? Negative 16 over 125 is equal to 158x over 25 minus 6 times 158 over 125, sorry, 125, yeah. So is this kind of just nasty fractions? Because after you find x3, what would be interesting to know? What the actual value is, right? So you can go back to the original polynomial and find out what it is. Second what? Calc. And then which one do I use? 0. And it asks you for a left bound. And then it asks you for a right bound. And then it asks you for a guess. And look what we ended up with. How good is that answer? Is that pretty good? And what's interesting on your calculator, you should know this if you don't, it saved that value as x. Like if I go back to the entry key and I go this right there, right? It actually saved the x value. Every time you do this, it resaves the x value. Like if you pick up a random calculator and do x and then enter, it'll probably give you some value. So we can actually check this. What was the fraction? It was 466 divided by what? 395 minus what? 466 divided by 395. So how close are we? We're pretty close. We are very, very close. So it tells us that right there tells us that our, so do we have an overestimate or an underestimate? We subtracted our guess, our estimate right there from the actual, and we ended up with a negative number. So do we have an overestimate or underestimate? Overestimate by how much? By, it's going to be 2, 3, 7, 8, and then we move it 1, 2, 3, 4 by that much. So is that pretty close? Yeah. Okay. So can someone just tell me what was the big downside to this method right here? So what's neat about this method? It's pretty cool because what? What's neat about it, even if you don't really like it too much? It gets close really quickly, and we did not have to use what function on our calculator. We didn't use zeros or calc or intersection, right? We just used it to deal with fractions, okay? And sometimes if I set up a nice one, you wouldn't have to deal too much with that. You could do it just by hand. Like theoretically, could you do this by hand? All of it, theoretically. In a semi-reasonable amount of time, yeah. It's really annoying because you get this huge fraction right here. At least it'll simplify a little bit. 125 cancels with 25, so, you know. It's even, so it's going to cancel a little bit. So that's one thing that's really nice about it. What's one thing that's really annoying about it, though? What was really annoying about this work? This is a calculus class, right? What was really a lot of what? A lot of algebra and a lot of working with kind of nasty fractions, right? Do you agree with that? So is there a way to write this so it'll help? There's a way we can simplify our work before we actually start the actual work on a problem, and this is how. So you could write this as f of what? Do you agree with that? What's the slope going to be? The slope at that point is going to be f prime at x1. So we have a slope and we have a point and a what? Slope. So what's the equation of that line? Can someone tell me? It's going to be y minus what? F of x1 equals times x minus x1. Okay, you're going to see this, and you have seen this many times. So now, if we want to find x2, what do we plug in for y? If we want to find x2, what do we have to plug in for y? 0. We want y is equal to 0. This is the exact same thing we did before, but we're generalizing it. This is the exact same thing before, but we're generalizing it. So if we do that, what do we end up with? Negative f of x1 is equal to f prime of x1 times x minus f prime of x1 times what? x1. I'm distributing it, right? Correct? What are we trying to isolate on this? We're trying to isolate what? X. Okay. So if we want to isolate x, what do we add to both sides?
F prime of x1 times x1.
We take this and we add it to both sides, right? So what do you end up with? You end up with f prime of x1 times what? Minus what? Equals what? F prime of x1 times what? X. Okay, so theoretically now, if we want to isolate x, what do we divide everything by? So x is equal to f prime of x1, x1 all over f prime of x1 minus f of x1 all over f prime of x1. Do you see that, everybody? What cancels? What can I simplify there? Yeah, they cancel, right? So what do you end up with? x2, because this is x2, right? Is going to be equal to x1 minus f of x1 all over f prime of x1. What we just did is super helpful because it can be generalized. It can be generalized. x2 is equal to x1 minus f of x1 over f prime of x1. What do you think, and this is just a guess for you, what do you think xn is going to be equal to if you want the nth term? X sub, the one before it, minus f of all over. This just means if you want the nth term, you take the one before it, right? People, there's a predisposition. People don't like writing minus signs in a way. I'm going to write the exact same thing. I'm going to write the exact same thing, just slightly different, and it's going to be what you see in your book. You're going to see this in your book. X sub n plus 1. What's the term before x sub n plus 1? X sub n minus f x sub n over f prime of xn. X sub n plus 1 represents the next term. So if you have a term and you want the next term, this is what you do. You have a term, you find the derivative, evaluate the derivative, divide it into the function at that point, and you get the next term. This gives you the next term. Why is this super helpful? Well, it can help because you don't have to go through all of that busy work before. You don't have to find the equation of the line every time. You can just use this formula. You can just use this formula to be equals x1 minus f of all over f prime of x1. Well, do we know what x1 is? 1 minus 1 cubed minus 1 minus 1, right? All over 3 times 1 squared minus 2 times, what does that equal? 1 minus, what's on top here? Negative 1 over what? 1. So that's the same as 1 plus 1 is 2. So that is x2. So we now have x2. What does x2 equal to? Sorry, x3, sorry. We want the next one. We have x2, so what's x3 equal? x2 minus x2 all over f prime of x2. You're going to do the same thing over and over again, but this time you have 2 is equal to, no, sorry, 2 minus what?
2 minus
2 cubed minus 2 squared minus 1 all over, what was the derivative? 3x squared minus 2x. So 3x squared minus 2 times 2. And what do you end up with? 2 minus 8 minus 4 minus 1 over 12 minus 4. So that's 2 minus 3 over what? 8. So that's equal to 13 over 8. Is this a little easier than what we were just doing? Yeah. You must memorize this. This right here. This is the huge thing you need for Newton's method, the huge thing. Now here's one thing that's still kind of annoying. On this, did we still run into some fractions already?
Mm-hmm.
If we had to do the next one, is this going to be kind of nasty?
Mm-hmm.
Do you agree that that's going to be kind of nasty? Because what's going to happen? You're going to have to cube 13 over 8. Is that going to be suddenly something you're going to want to use your calculator with? Yeah. So how can you help this? X to the fourth. Oh, to the fourth. You're going to have to use your calculator. You're going to have to use your calculator. So just to get this on tape, what we have here is a new method, which is you put in y3 as the calculation of the next value based on just x. And then you can type in y3 at the first value and then keep on doing second entry. Or you can just do it as one function composition, which is really, really cool. Good job, Iggy.